Okay, section 2 of chapter 2 is the structure of the atom. Right there. Okay. So the atom and the biological cell are very, very similar. Okay. You have a nucleus, just like you do in a cell. Okay. And that's where all the atomic atoms' mass is, which is basically true for a biological cell also. And there are three principal particles inside of a cell. You have an electron, which is a negatively charged particle that exists outside of the nucleus. And so that's demonstrated right here, okay, in all kinds of different ones. So it's often referred to as an electron cloud, okay. And the way that the electron was discovered was J.J. Thompson in 1897, so just over 100 years ago. Chemistry has made leaps and bounds in the last 100 years. He's a British physicist, and he basically took electrons between two charged plates, and they always went towards the positive plate. And so he was able to calculate the ratio of the mass of the electron to the charge, but he didn't know either the mass or the charge. And from that, he came up with what they call the plum pudding model, which is demonstrated here, and this is actually a video that will be on the resource page, in which you basically had an even mixture of your electrons and your protons, which we haven't got to yet, but your protons here, okay? Next came, just 12 years later, came the mass-to-charge ratio of an electron. This was performed by Robert Millikan, a U.S. physicist, and he was able to calculate the charge of the mass-to-charge ratio, not knowing necessarily either, but he was able to do a ratio. And so, again, this is a video that emanates this basically where he took oil droplets and he made an aerosol of them. And then the oil droplets fell through this plate, and then this will show down. And this plate, you see, is a positive charge, and there's a plate down below. It's a negative charge. And he was able to vary the charge to get that electron, or that oil droplet, to basically bounce between the positive and negative, staying in a very narrow area. And because of that, he was able to size that oil droplet, and based on the charge he had to get there, he was able to get the mass-to-charge ratio. And then the last one is Ernest Rutherford. Ernest Rutherford did what we call the gold foil. This was just 2 years later, another British physicist. They don't really, even chemistry wasn't the one doing this field at this time. And showed that the atom is mostly empty space. So this was a huge deviation from the plum pudding model. And so basically, this is another video, okay, that shows that when they took alpha particles, okay, and shot it through gold foil. And gold foil is something you can still buy today. It's used in decorating, of all things. It's called gold leaf at that point. But basically, it's a very, very thin layer of pure gold. And what's going to happen if you play this video is that you'll see that this dot right here is what lights up the most. Occasionally, and just very occasionally, you'll see other dots like here, here, and there's one here, and there's also one over here that light up. Okay? Now, basically, think about if you were doing this experiment. For all practical purposes, this would be like throwing a tennis ball against the wall. What do you expect that tennis ball to do? Do you expect it to go through the wall, or do you expect it to come back at you? So the expected was the fact that most of the alpha particles would be basically bouncing back and forth either here or here. But instead, most of them actually went through. And so this figure on the right shows the fact that the ones that went through, actually, the alpha particles are positively charged. So when they hit there, this is a positively charged nucleus, and it caused it to bounce back. If it came close to, this one shows it better, if it came close to the nucleus but didn't actually hit the nucleus, then it actually deviated just a little bit. But most of them go straight through because it's traveling through the electron cloud. And I say we use the term cloud because it's very similar. If you look up in the sky and you see the white clouds from the ground, they look solid. But if you've ever been on an airplane, you know that you can fly through the clouds. It's a water vapor that appears solid from the outside, but is not. And so this electrons basically do that. Okay, they give the empty, they make basically the atom empty space. That's why it's called an electron cloud. And so this is the end of section 2.2.